Okay, for the empirical formula, what we have in the percentages is the ratio between the masses of the elements. What we need to have instead is the ratio between the moles. But we can calculate moles from masses, yes? Because when it says that it has 32.8 grams of chromium and 67.2 grams of chlorine, is the same as 32.8% if we are talking about a total mass of the compound of 100 grams. So these are ratios in masses. But when we have a formula, for example, H2O, water, these two and this one that we don't draw, they represent moles. They don't represent masses, yes? So what we need to do is to transform these percentages or masses into moles. So what we are going to do, I build a table because it's much easier for you, and this is going to be very easy for you to remember how to do them. So in this case, we are going to put the symbol of the elements here, chromium and chlorine. Okay? And we are going to write the values of the percentages in this, at the top of this cell. So in this case, it's going to be 32.8%. And I don't use the percent symbol, okay, because it can be masses as well. And 67.2. Then those values are going to be divided by a number. Which number? The AR. Which is AR? The atomic mass unit. Where do we get this atomic mass unit? Exactly, from the periodic table. So the only thing that we need to do is to look for the chromium and put the value here. 52. Exactly? Well, 52 is good enough. And chlorine is 35.5. What I'm doing with this, I'm calculating the number of moles of chlorine and chromium that we have. Okay? Because the total mass is 32 divided by 52, which is 1 mole. The mass of 1 mole is going to give me the number of moles. And we want those number of moles to see which is the formula for this particular compound. Do you understand? Now, if you make these calculations, it's going to give you 99.99% of the time a decimal number. So we are going to write down the answers or the values of this division in the next cell. Can you give me the values for that? Louder, please. 630. And the other one? .892. Now, can we express this chromium 0.630 and chlorine 1.892 as a formula? No, we don't use that. Instead of that, we're going to transform that ratio between the moles in whole numbers. And a good thing to do is to divide by the smallest number that we have. So in this case, it's going to be 0.630 and 0.630. So I divide both numbers by the same number, the smallest one. Okay? So this is going to be 1. It should be around 3. Okay? And normally we are going to have like 2.9 or something like that. We round up. Unless we have exact numbers like 2.75 or 2.5 that we need an extra step. But for these, it's going to be okay. So which is the formula? Chromium is going to be 1 time. And chlorine is going to be 3 times. So we don't write that like that. We put chromium, chlorine, 3. And that is going to be our formula. Which formula? The empirical formula. Why the empirical formula? There are many compounds that have a formula that is minimum, okay, like this one, but the molecular formula is going to be a multiple of that. So that is going to be the third concept that we covered today, which is going to be molecular formula instead of empirical formula. Okay? Do you understand this? Okay, perfect.